Okay, so now let's graph the reciprocal trig functions, starting with cosecant. So cosecant starts with c. So if you watched the previous video, you'll understand what I'm talking about here. But cosecant starts with c, and that means it's a reciprocal of the function that starts with s, which is sine. Cosecant of is reciprocal of sine. So here's the trick that we're going to do. I'm going to graph this. Because cosecant is reciprocal of sine function, basically we're going to graph sine and then take reciprocal of a value. So I'm going to use a lighter color to quickly graph my sine function, mid, high, mid, low, mid. Okay. I'm just graphing sine as a dotted graph because this is not my final graph. We're using this to help me graph cosecant. So then the sine function graph looks like this. And sine functions have values at zeros, right? So if you think about it, sine of, let's see, sine of 0 is 0. Sine of pi is 0. Sine of 2 pi is 0. But that's not what we're graphing. We're trying to graph reciprocal of sine. So what is reciprocal of 0? Well, reciprocal of 0 is 1 over 0, which is undefined. And how do we graph an undefined value? We graph with asymptotes. Okay. Wherever the zeros are for the sine function, that's going to be reciprocal. That's going to be the asymptote for the reciprocal sign. So I'm going to graph my asymptotes at zeros. Your cosecant function have asymptotes. Okay. And then sine also has these value of 1. Pi over 2 is a 1. 3 pi over 2 is negative 1. And what's the reciprocal of 1? Reciprocal of 1 is still 1. It's the same. Reciprocal of negative 1 is also negative 1. It's the same. So guess what? Cosecant will also have the same points as sine. So you got these points, and guess what? You just got to trust me on this. Cosecant graph will look like this. You're just going to have the u's over those points. Some u's going upwards, some u's going downwards, but that is your cosecant graph. And if you want to make it look nicer, then what you should do is draw those dotted graphs, because that's not part of my cosecant, right? Those are sine graphs, so I'm going to erase those. And this is your final product. That's the cosecant graph. Okay. So then now let's talk about domain. Now this has asymptotes, right? And guess what? It's going to be similar to how we stated the domain for tangent. You're just going to have to skip every asymptotes. So your asymptote starts, how often? It starts every pi radians. Every pi radians are going to be your asymptote starting where? It could start anywhere. You could start at 0, pi, or 2 pi. It doesn't matter. What is your first asymptote that you see on your graph? Right? That's up to you. So hold on, I drew my, let me make it lights there. So my domain for cosecant is going to be all numbers except the first asymptote I'm going to see is 0. I'm just going to say, okay, the first asymptote I'm going to say is 0 plus every pi radians. My asymptotes repeat every pi radians, so plus pi times n. That's my domain. If you decided to say, okay, Ms. Park, I think I'm going to say that my asymptote starts at pi, then okay, you can say this is pi plus pi n. Or if you want, you could say 2 pi plus 2 pi n, or you could also say negative pi plus pi n. Doesn't matter, okay? If you want to do negative pi plus pi n, that's fine. It doesn't matter. As long as you tell me whatever first asymptote that you see plus pi n. Now for the range, cosecant It's not all real numbers because guess what? The graph skips between -1 and 1. There's nothing between -1 and +1. So there's one way you could write it. You could say range is less than or equal to -1 or greater than or equal to +1. So all the numbers below -1, right? Or all the numbers above +1. That's your range. Or you can also write it as the interval notation, -infinity to -1 and +1 to +infinity. Okay, that's the range. Now for the last part, it's not asked on the handout, but I do want to clarify is the period. Okay, period of cosecant. What's the cycle that is repeating over and over again? Do you think this is the graph that is being repeated? No, because if that was the period, then you should have U's everywhere. That's not the case. You got a U going up and a U going down. And that's one period. This is a cycle that is being repeated over and over again. So that period from here to here is 2 pi. Period of cosecant is 2 pi. Remember that. All right, now the next part is secant. Secant starts with S, so it's going to be a reciprocal of cosine. Starts with S, so then this is a reciprocal of cosine. So same process, I'm going to graph my cosine first. I made low, mid, high, and same idea. Every zeros at cosine, right? Your x-intercept zeros are all here. Reciprocal of 0 is undefined. So that's where your asymptotes are going to be now. Asymptotes. Okay, same thing. Reciprocal of -1 is -1, reciprocal of 1. And I'm going to draw my U's again. The U's don't have to be perfect. As long as you just tell me where the asymptotes are and where these 1s and -1s are, you can just draw your U's. That's all I need. Okay. So then I'm going to erase the blue dots, dotted lines again, because that's not what I want as my final product. And here is your secant graph. It's very similar to cosecant, right? It's just that your asymptotes are in different locations. This time your asymptotes are at pi over 2, 3 pi over 2. Okay, so we can state our domain, which is going to be all real numbers except your asymptotes. So your asymptote, doesn't matter where you start, I'm going to say at pi over 2. Okay, I'm going to choose pi over 2. Plus, and how often are these asymptotes repeating? Let's see here. How far apart are they? They're pi radians apart. Every pi radians from pi over 2 are my asymptotes. So then plus pi times n. If you want to start with -pi over 2, that's totally fine. It's up to you. Range is going to be the same thing. It's going to be less than or equal to -1, greater than or equal to 1, or you could write it as an interval notation if that's what you prefer. That is secant. Right, so now for cotangent. Cotangent is reciprocal of tangent. So here's what I'm going to do. I'm going to choose a lighter color and graph tangent first. Tangent itself have asymptotes. So we're going to draw asymptotes first. Okay, I'm drawing the lighter color again because I'm going to draw over tangent. In the middle of the asymptotes are the x-intercepts. I'm going to label this up 1, make a darker +1, -1. And I'm going to go up 1, down 1. Here's my tangent. And I'm going to graph that everywhere. Once you have your tangent graph, right, now we're going to have to graph cotangent. And here's my trick. just like we did earlier, okay? Your asymptotes are going to be the reciprocal of 0, right? Again, reciprocal of 0 was 1 over 0, which was undefined. So tangents asymptotes were at pi over 2 and had zeros at 0, pi. Now all those zeros will become the asymptotes for cotangent. We'll choose a brighter color. Cotangents, asymptotes at reciprocal of 0. Okay. Reciprocal 0. And then what happens? Again, reciprocal of 1 is still 1. These points don't change. Reciprocal of 1 is still 1. Reciprocal of -1 is still -1. These points don't change. Reciprocal of -1. And guess what? You got points in the middle. Reciprocal of undefined is 0. And if you connect them, now you got a cotangent graph, which looks similar to tangent, but now the arrows, the graph, have the left hand going up. This is cotangent graph. Graph your tangent, and then your cotangent over it. So my cotangent is going to be the red graph. I know I'm not going to bother erasing every single pink here, but we use tangent to help us graph cotangent. Okay. So then once we have that, now let's talk about domain. Let's see. It's going to be skipping at every asymptote. So any of the first asymptote that you see, let's go with pi. Okay, that'll be all real numbers except pi, because that's the first asymptote that you see. If you want to say 0, that's fine. You can say 0. Or if you want to say -pi, that's fine too. You can put -pi. Plus, how often are these asymptotes repeating? Let's see. What's the radians between the asymptote? It's pi. Every pi radians are your asymptotes, right? Pi, 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 radians apart. So plus pi times n. If you want it to do 0 plus pi times n, that's totally fine as well. Okay, and range is all real numbers. And that's the graph of cotangent. Period of cotangent, okay, it's still pi. This is one cycle of cotangent. That's one cycle. And that is pi radians apart, so period is pi.